Okay, welcome to week 3, lessons 1 and 2, group discussion. So, went through the prep, and again, it was interesting trying to remember what the domains were for the originals and being able to answer what the range would be. The inverse of sine, we were given that the range, because domain is negative pi halves to pi halves, that makes the range negative pi halves to pi halves. And you continue to go down cosecant inverse, its range would be negative pi halves to 0, or not including 0, or 0 to pi halves not including 0. But it does include negative pi halves and pi halves. So that was part of the prep, and I went ahead and I did all of those. And then you had the negative sign, the inverse of sine for square root of 3 over 2. I went to my unit circle. I went and I found where sine is square root of 3 over 2, and that's the angle of pi thirds. Cosecant inverse of 2. So what I did for this one is I found where sine is 1/2, so cosecant would be 2, and that's the angle of pi 6, and that's kind of how I continued to go about that. So the question 5 in the prep, use the fact that the sum of the angles of a triangle add up to 180 degrees to solve for the missing angle. Then you can use trigonometric functions to solve for missing sides. So I'm trying to find the triangle. So it gave us a triangle a right triangle where we have 90 degrees and 42. So you add those together, it's 132 degrees minus from 180, and that gives us the 48 degrees is left for our angle alpha. From there, you can take the tangent or since we're given the opposite of 42, we know that we know that sine of 42 equals 7 over c. And so we know that c equals 7 over sine of 42, which gives us c is equal, once you plug that into your calculator, you get the c is equal to 10.5 if you solve to 1 decimal. And then we can use tangent to find, actually we could use cosine to find, a. So I prefer to use cosine. I have my two, actually, sorry, not cosine. I would use tangent because I'm given 7 and 42. Since I am not given the hypotenuse, cosine wouldn't be a good one to use. That gives me 2 pieces given to me. So I have tangent of 42 equals 7 over a. So a equals 7 over tangent of 42. Plug that into your calculator, round it, 7.8 is what a is equal to. So that's the question 5 for the prep. As far as for the extension problems, tangent of 5 pi 6, I struggle with these. I always end up going to my unit circle. So that, I get 5 pi 6 is negative 1 over, tangent of 5 pi 6 is negative 1 over square root of 3. So if we take the inverse of tangent 1 over 3, then that's going to give us our, sorry, I'm trying to find my notes. So that's the same as cosine over sine. Oops. Is square root of 3, and which is equivalent to cosine equaling square root of 3 over 2 and sine equaling 1/2. And so since I'm looking for the cosine of that, I know that cosine is square root of 3 over 2. So there's a couple of those. I went ahead and finished going down them. Now, the triangles I found, I find these fun, and I found your videos very informative and helping to go through all the difference, making sure that you use the 2 pieces given, which is what I did with question 5 on the prep. So on the first one, to find b, you take 6 squared plus b squared equals 15 squared minus the 6 over. So you get, oh, excuse me, sorry. You get this, you get b equals the square root of 15 squared minus 6 squared. 15 squared is sorry, 150 plus 75. 225 minus 36 is 189. So the square root of 189, and it doesn't say how many decimals. So again, I'm rounding to I'm rounding to 1 decimal. So plug that into the calculator. Square root of 189 to 1 decimal is 13.7. So b equals 13.7. And then from there, because we have one side and the hypotenuse, it's easy to utilize sine and cosine. So sine would be, so to find the angle of A, we'd want opposite over hypotenuse, which is sine. So the sine of 16 over 5 gives us about 20, roughly. I don't like that it doesn't tell how many decimals to round to. I'd say roughly 23.6 degrees. B, which would be the cosine of 6 over 15, would give us 66.4 degrees. You add all those together, they do equal 180, telling you that you've got the right information. On the second one, where we have one side, 2 angles, this one makes it a little bit easier because we can find the third angle, which to me is one of the harder ones to find. So 90, and so I know that A and 280 and 28.5 need to equal 90 to give me my 180 degrees, so that I know that this is 61.5. Angle alpha equals 61.5 degrees. Then from there, we can continue to use our trigonometric functions utilizing the hypotenuse and the given angle. And so eventually we come out to A is roughly 5.6 and B is roughly 3. And that's our sides. So this one I struggled with a little bit more. So you draw a triangle that you have 125 feet for the tower, and then you have the 90-degree angle at the bottom and then you have the 32-degree out where you're standing, or route out at the end of the guy rope. I always thought they were called guide ropes, not guy wires. I thought they were called guide wires. So you draw the picture, giving you your right triangle. And so to find out how long the hypotenuse is, we've got to figure out how long the base is. So we have two angles, 90 and 32. So that gives us 58 degrees for our third angle. And because we have adjacent, we actually didn't even really need that, because I can take opposite. I can take the sine of 32 equals 125 divided by h. And so if I fix that, so sine of 32 equals 125 divided by h, and I plug in, I multiply, or sorry, divide. So it's 125. Man, sorry about this. I'm having a hard time tonight. So we need to get the hypotenuse by itself, our wire. And so to do that, you divide both sides by 125. And then you need to invert them so that the hypotenuse is a whole number. So it's 125 divided by sine 32, plug that into the calculator, and approximately 236 feet, or 235.9 feet for our guide wire. So again, that one I found, I struggled with that, which is also why I struggled explaining it. Your sister Orm's house, a teacher in the BYU cell tower, is located 210 feet from the edge of the road above the cell tower. The above. I really didn't understand that. Why? If they're saying the guide wire wouldn't be, if you're running the guide wire to the edge of the road or something, if you'd be able to do that. And if that's the case, what I would do is we take our 235-foot guy wire, and we take 125 squared plus distance from road squared. I'm just going to call it d squared. So, oops, plug these into my calculator. So we have, I'm just going to say 236 for the guy wire. So, sorry, we have the square root of 236 squared minus 125 squared. And it's less than the 210 feet. So you could put it, it would have enough room. So to run the guy wire and not run into the road. So yeah, you could do that. A common question that can be answered through right triangle trigonometry is the height of an object. In many towns in the United States, you'd like to know the height of the tower. Note the following data is fictional, so begin by walking away from the tower for some distance and measure the angle of elevation to be 20 3.5. So we have our two angles. We have the right angle and we have the 23.5 angle. 23.5 from 90 is 66.5. So that's our third angle. If we walk out, so this is the triangle on the side of a triangle. And so when you draw the picture, we have our right triangle is 23.5. And then we have our 19.5 triangle. So there's a few different ways that we can look at this. So doing the triangle inside of a triangle, we know that 23.5 from 180, so that we can work on our obtuse triangle, is 156.5. And the reason why we need that is then we add the 19.5, which gives us 176, and that gives us that our top angle at the top of the tower from inside is 4 degrees. And then we also know that I'm confusing myself. I don't know where to go from here. Let me see if I can. So we have the height of the tower. We have x for the distance we walked the first time. Second distance is x plus 50. So excuse me. Yeah, I'm confused on this one. I'm going to have to go back and watch your video again. So yeah, I will go back and do that, and I will figure out how to do question 2. But that's my broadcast for tomorrow. I decided to do it tonight because my wife's birthday is tomorrow, so we're going to go do stuff as a family. So have a good night.